This is a solution to number 23 from homework 4.2 day 1, where we're going to graph the rational function h of x is x squared over x squared minus 9. The first thing you want to do when you're graphing a rational function is you'll want to factor the numerator and the denominator. So x squared minus 9 is a difference of squares. That's going to factor as x plus 3 times x minus 3. Now we're ready to do the analysis. So we need to find the x-intercepts if they exist and their multiplicities. To do that, to find the x-intercept, really we're looking for values where y equals 0. Since this is a fraction, we can focus on when the numerator is 0, but we have to be careful that the denominator is not also 0. In this case, we have an x-intercept when x is 0, and that is going to be at 0, 0. With multiplicity, here the multiplicity, we look at the power of the factor that gives us the x-intercept. So since it's x squared, this has even multiplicity because the multiplicity of this 0 is 2. The y-intercept, to find the y-intercept, we're going to find f of 0. So f of 0, in this case, it's easiest to look at the unfactored version of the function. So f of 0, we're going to put 0 in for x, so we're going to get 0 over negative 9, which is 0. So the y-intercept is 0, 0. Actually, if you have an x-intercept at 0, 0, you also have a y-intercept at 0, 0. Next, we're going to look at vertical asymptotes. To find vertical asymptotes, we're going to focus on the denominator. So here we're going to look for values that make the denominator to 0, but we have to make sure the numerator is not also 0, because in that case we may have a whole. So in this case, we have the factor x plus 3 is going to give us a vertical asymptote at x minus 3 with odd multiplicity, and the factor x minus 3 is going to give us a vertical asymptote at x equals 3, also with odd multiplicity. And infinite asymptote, we're going to think about the end behavior. For that, we're going to look at the degrees of the numerator and the denominator. In this case, the degree of the numerator is 2. So here, n equals 2. The degree of the denominator in this case is also 2, right? Because we have x squared here and x squared in the denominator. When we have the same degree in the numerator and the denominator, we have a horizontal asymptote, and its equation is the ratio of the leading coefficients. In this case, both are 1. So we have a horizontal asymptote at y equals 1. And the last thing we need to say, does this function h of x intersect its infinite asymptote? To find that, we're going to take h of x, which is equal to x squared over x squared minus 9, and we're going to set it equal to the equation for the infinite asymptote, which is 1. Multiplying both sides of the equation by x squared minus 9, we'll get x squared equals x squared minus 9. Canceling out the x squared, we'll get 0 equals negative 9. That is never true, so we can say no, h of x does not intersect y equals 1. Now we're ready to do our graphing. So let's put on our x-intercept and y-intercept. They're at 0, 0. And I'm going to put a little e next to that x-intercept because it has even multiplicity. Then let's go ahead and put on our vertical asymptotes. We'll let each unit be 1 here. So we're going to have a vertical asymptote at x equals 3. I'm going to put a little o at the top because this has odd multiplicity, and x equals negative 3. So our other vertical asymptote, x equals negative 3, also with odd multiplicity. And I'm going to put on the horizontal asymptote at y equals 1. And now we're going to have to sketch this graph. So the only point we have is the x-intercept 0, 0. We have even multiplicity, which means the graph is going to bounce off this x-intercept. So either we're going to have something bouncing going downwards or something bouncing going upwards. If we were to go upwards, we would end up crossing that horizontal asymptote, which we just found that we don't cross the horizontal asymptote, which means that this graph is going to be going down off these x-intercepts. So they're going to be going down, and as we approach the vertical asymptotes at plus and minus 3, the graph is going to get closer and closer to those values. Let's go to the right of the vertical asymptote at x equals 3. So we're going to focus on that value. So this is a vertical asymptote with odd multiplicity. That means if the graph is going down on the left side of the vertical asymptote, when we cross over to the right side, it's going to be going up. So we're going to have it going up here. And as x gets larger and larger and larger, my graph is going to approach the horizontal asymptote. So that's going to be one branch. And now let's go to the left of the vertical asymptote at x equals 3. So when we do that, this is also a vertical asymptote with odd multiplicity. So that means if we're going down on the right side of x equals -3, when we go to the left side, our graph is going to be going up towards that vertical asymptote. And then as x gets smaller and smaller, the graph is going to approach that horizontal asymptote but never touch it.